Hello everyone, welcome to the third lesson of the second term. So we're going to discuss about work, energy and power. So we're going to start with the concept of energy. Energy, it is the ability to do work. You know that definition from the primary level. It is denoted by E and it is a scalar quantity. Energy is measured in joules. Then we have principle of energy. Energy cannot be created or destroyed, but transferred from one object to another, or transformed from one type to another type. With mechanical energy, it is the sum of kinetic and potential energy. It is denoted by EM, it is measured in joules, and it is a scalar quantity. We have two types of mechanical energy. It is kinetic energy and potential energy. Let's start with kinetic energy. It is the energy that an object has due to its motion. It is denoted by EK or K. It is measured in joules. It is a scalar quantity, and it is determined by the mass and the speed of the object. The formula that is used to calculate for EK is EK equal to half mv squared, where EK stands for the kinetic energy of an object measured in joules. Then mass is the mass, m is the mass of an object in kilograms, and v stands for the speed of the object in meters per second. Let's consider the first example. We have to calculate the kinetic energy of the following objects. The first question is for an Olympic sprinter of mass 60 kg. She's running with a speed of 10 meters per second. Then number two, we have a car with a mass of 3,300 kg traveling at a speed of 80 kilometers per hour. Then number three, we have a ball of mass 100 grams, which is moving at 25 meters per second. Let's start with the solutions for the first question. Number one, we're given the mass, which is 60 kg, and the speed, which is 10 meters per second. The formula to use is EK equal to half mv squared. Then we make substitution. Half times 60 times 10 squared is equal to 3,000 joules. The second question, we're given the mass, which is 3,300 kg. The speed is given in kilometers per hour. We need to convert it into meters per second. So we divide 80 by 3,6, we get 22,22 meters per second. What you can do, you can multiply 80 by 1,000 and divide it by 3,600. Then you get 22,22 meters per second. Question number two, then we make substitutions. Half times 3,300 times 22,22 squared. Then we get 814,651,86 joules. That is the kinetic energy. Number three, we have the mass, which is 100 grams. We divide 100 by 1,000, we get 0,1 kilograms. Then the speed is 25 meters per second. Then we substitute to the formula, we get 31,25 joules. Let's go to potential energy. Potential energy is the energy that an object has due to its position. It is denoted by EP or U. It is measured in joules. It is a scalar quantity, and it is determined by the mass and the height of the object. So the higher the object moves away from the ground, the bigger the height, hence the bigger the potential energy. So the potential energy is measured by EP equal to mgh, where m stands for the mass of the object, g for the gravitational acceleration, which is 9,8 meters per second squared, and h stands for the height of the object above the ground. Let's consider example number 2.1. Calculate the potential energy of the following objects. Number one, we have a stone of 2 grams on the floor. Number two, 5 kg on a height of 8 meters above the ground. 2.2, we have a Boeing 737-300 airplane with a potential energy of 550 gigajoules and traveling at a height of 300 kilometers above the ground. We need to calculate the mass of the airplane. Let's consider the solutions together. Number one, we're given the mass in grams. We need to convert it into kilograms. We divide 2 grams by 1,000. We get 0.002 kilograms. Then gravitational acceleration is 9.8 meters per second squared. The height is 0 meters. So we use the formula EP equal to mgh. Then we make substitutions. Then we get the answer, which is 0 joules. So we made calculations here because the questions was calculate. They didn't say what is the potential energy. So number 2.1.2, we've given the mass 5 kg, which is 8 meters above the ground. The mass is 5 kg. G is 9.8 and the height is 8 meters. We use the formula and we make substitutions. The mass will replace it by 5, G will replace it by 9.8, and the height will replace it by 8. Then we make calculations to get 392 joules. Number 3, so we have the potential energy there, which is 550 gigajoules. We convert it into joules, which is 550 exponent 9 joules. The height is 300 kilometers. Convert it into meters, multiply by 1,000, we get 300,000 meters. We use the formula and we make substitution. Okay, so we make m the subject of the formula by dividing by 9.8 times 300,000 both sides. Then we get the mass, which is 187,075 kilograms. Okay, which is the mass of the airplane with the passengers, of course, and the fuel. Remember, the fuel of the airplane can go even up to 45,000 liters. Principle of mechanical energy. Mechanical energy in an isolated system remains constant. A system is isolated when the total net external force is 0. So which means the initial mechanical energy is equal to the final mechanical energy. Then we know that mechanical energy is the sum of kinetic energy and potential energy. Then we get half mv initial squared plus mg h initial, which is equal to half mv final squared plus mg height final. Let's consider example number 3. A child of mass 88 kilograms slides from rest down a frictionless slide at the playground. The height of the slide is 2 meters. You need to ignore air friction. 3,1,1 is the mechanical energy of the child conserved. You need to explain your answer. Number 2, calculate the potential energy of the child at the top of the slide. Calculate the speed of the child at the bottom and calculate the mechanical energy at the top of the slide. Okay, let's consider the solutions. 3.1, yes, it is conserved. The question was, is the mechanical energy of the child conserved? Explain your answer. The answer is yes, it is conserved, because there is no non-conservative force that is acting to reduce the mechanical energy of the system. Number 2, then we have the mass of the child, which is 38 kilograms. The height is 2 meters and G is 9.8. Use the formula and we make substitution. With 8 times 9.8 times 2 is 744.8 joules. That question. So the initial mechanical energy equal to final mechanical energy. Then we put it there, the kinetic energy and the potential energy. Then we make substitution. Initially, because the child is sliding from rest, so kinetic energy is 0. Initially, the potential energy, because it's a 2 meter above the ground, so the mass is 38, G is 9.8, then the height is 2. So we substitute. Finally, we put the mass there. The final velocity is what we're looking for. So the height is 0 finally, so which means potential energy finally is 0. Then we need to make V the subject of the formula. Then you apply the square root both sides and you divide by the mass to make V the subject of the formula, and you multiply by 2 both sides. Then you get the final velocity, which is 6.3 meters per second. Then the fourth question, mechanical energy, you know that it is the sum of kinetic energy plus potential energy, which is half mv squared plus mgh. Then we substitute. The initial velocity is 0, which means the initial kinetic energy is 0. The initial height is 2, then we substitute. The answer is 744.8 joules. Okay, the first learner's activity, you need to do it by yourself at home. A rock of mass, 5 kg, is pushed over the edge of a cliff, which is 200 meters high. Ignore air resistance and calculate the speed of the rock at the bottom. You need to calculate the kinetic energy of the rock at the bottom of the cliff. Number 3. A small brick of mass 700 grams is projected vertically downwards at a velocity of 1.25 from the top of a building of height 25 meters. Ignore the effects of resistance. Calculate the magnitude of the velocity at which the brick hits the ground. For point 2, on reaching the ground, the brick penetrates 10 centimeters into the ground before it comes to rest. You need to calculate the work that is done on the brick while penetrating the ground. Example number 4. A pendulum with a bob of mass 5 kg is held stationary at a height h meters above the ground. When released, it collides with a block of mass 2 kg, which is stationary at point A. The bob swings past A and comes to rest momentarily at a position of quarter height above the ground. So we're given there the diagram. Immediately after the collision, the 2 kilogram block begins to move from point A to point B with a constant speed of 4.95 meters per second. Ignore frictional effects and assume that no loss of mechanical energy occurs during the collision. So we need to calculate the kinetic energy of the block immediately after the collision. Then we need to calculate the height, h. First question is to calculate the kinetic energy. Okay, let's do that together. Example number 4. Okay, example number 4. So we need to calculate the kinetic energy. EK equal to half mv squared. So let's substitute. M is 2 kg. We substitute 2. The speed is 4.95. Then we substitute. That is the answer. Half times 2 times 4.95 squared is 24.5 joules. Okay. 4.1.2. We need to calculate the height which is reached by the objects after the collision with the block. So we can use this formula: loss of potential energy by the bob is equal to the gain of kinetic energy by the block. What makes the bob not to reach the initial height is because it has lost energy due to colliding with a stationary block. So which means the potential energy of the bob which is lost, is the same as kinetic energy which is gained by the block. So the potential energy will be mg, which is lost, so initially the height was h, and finally it is 1/2. So if we say h minus 1/2, h will get 3/4 height, 3/3 of the height. Then this is equal to kinetic energy, which is gained is 24,5. Then we make h the subject of the formula here. We get 24,5 divided by 3 times 4. Then we get 0,66666, which is rounded off to 0,67 meters. Okay, so we can also use this formula. The mechanical energy of the system remains the same, which is initial mechanical energy of the system is equal to the final mechanical energy of the system. So we have mechanical energy initial of the bulb plus mechanical energy initial of the block, which is equal to final mechanical energy of the bulb plus final mechanical energy of the block. Then for the bulb, we have EK initial plus EP initial. That is from the bulb plus EK initial plus EP initial for the block, which is equal to with EK final plus EP final for the bulb. Plus for the block, we have EK final plus EP final. Okay, let's substitute. Initially, the bulb is released, its kinetic energy is 0. It's held at a height h above the ground. The block, its kinetic energy is 0 initially, and its potential energy is 0 because it was stationary. After collision, the bulb reaches a height where it is stationary, kinetic energy is 0. Then its potential energy is mg times the quarter of the height plus the block. Its kinetic energy, I've calculated it, is 24,5. The potential energy is 0 because it is still moving along the horizontal on the ground. Let's substitute Bob. Its mass is 5, G is 9,8, the height is unknown. Then equal to the mass of the Bob is 5, G is 9,8, 1/4 height plus 24,5. And you can take this to the left. Then we get 49H, which is 5 times 9,8, minus here we get 12,25, which is 5 times 9,8 times 0,25, which is equal to 24,5. Then making height the subject of the formula, we get 36,75 height, which is equal to 24,5. Then we divide both sides by 36,75. To make the height the subject of the formula, then we get 0,67 meters. Okay, that is the answer. Let's go back to our questions. Okay, so we've managed to calculate age. Learners activity number 2. A block of 2 kg is dropped from a height of 10 meters above the ground as shown below. So the first question, what is the kinetic energy of the object on top when it is dropped? Number 1.2, what is the potential energy of the object at the bottom when the object hits the ground? 1.2, calculate the kinetic energy when the object hits the ground. Calculate the potential energy at the top when the object is dropped. Calculate the speed of the object when it is 2 meters above the ground. By using, number 1, we use equations of motions, and we also use energy principles. Activity number 3. A 5 kilogram block is moving at 2 meters per second, horizontal along a frictionless surface AB. It then moves along a frictionless inclined plane BC. It comes to a stop at point C. What is the speed of the block at B? You need to calculate the height h reached by the block. Then you must use Newton's law, which is F net equal to ma, to calculate the distance BC. Then as activity number 4, the pendulum consists of a bob with a mass of 200 grams and light inelastic cord. The bob is pulled back until a height of 2 meters above the ground. When released, it swings past point A and comes to rest at a point h/2 above the ground. Okay, you can see the diagram there. What is the kinetic energy of the bob at 2 meters above the ground? What is the kinetic energy at the position h/2 above the ground? What is the potential energy of the bob at A? What is the numerical value of h? Without making calculations. Then you need to, okay. Acceleration of the bob at position indicated as h/2 above the ground. What is the acceleration of the bob at the position indicated as h/2 above the ground? Then 3.2 or 4.2, calculate the speed of the bob when it passes point A. Okay, that is the end of the lesson. Thanks for taking part of the lesson and all the best. Learn, grow, and succeed. Thanks a lot.